If you're writing software, there's a very good chance that you're in the habit of using a refactoring tool or a linter or a code formatter or maybe even a code searcher that's more advanced than just grepping. There's actually a fair chance you've used all four of those tools very recently because they're all fundamentally useful tools no matter what language you use. And they're also fundamentally operating in a similar way. So you might ask, how? You might know, conceptually, it's not that hard. What you do, I think of it as a two-phase process. What you do is you write a few regular expressions, and then you write a few more regular expressions, and then their weight and complexity drives you completely mad, and you spend the rest of your life in an asylum gibbering. And then phase two is your children grow up, and they realize that was the wrong way to do it, and they do it the right way by writing a proper code parser. And the parser takes the text file and turns it into a logical representation of the structure of the code, which gets called an abstract syntax tree. And then you look at that tree, and either you rewrite the tree for refactoring, you look through it for searching, you critique it for linting, or you just write it back out neatly for pretty printing. That's the basic idea. Now we dig in properly, because there are a lot of juicy details once you pop the lid off it. I'm joined today by Jonathan Schneider, and he's one of the authors of OpenRewrite, which is an open source refactoring and code analysis tool that actually handles a surprisingly large number of different languages and different file formats, and works all those different tricks on them. And Jonathan's going to take us through how you really build a system for wrangling source code, including all the thorny edge cases like languages that are sometimes whitespace sensitive and developers that are manically whitespace sensitive. That comes up a lot too. So let's get started. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Jonathan Schneider. My guest today is Jonathan Schneider. Jonathan, how are you?
Doing super well. How are you?
I'm very well, very well. I am looking forward to going back to algorithm school with you.
Absolutely. Always looking forward to going there.
Excellent. Before we get into the guts of how OpenRewrite works, I'd like to know how you find yourself in a world writing parsers galore, I assume, and abstract syntax tree manipulators and all that stuff. Where did you start?
Yeah, this story began almost 8 years ago. I was working on engineering tools at Netflix. And at the time, Netflix, pretty small engineering team relative to the other sort of FAANG companies in the area. But they had this special cultural tenet called freedom and responsibility, which meant as a member of a central team, you couldn't impose any constraints on what product engineers did. So I find myself on engineering tools trying to help people move forward, for their own benefit as well. Like that could be moving forward from one language version to another, or we were trying to get off of an old logging library called Blitz4j that we had written internally, and we're trying to move to SLF4j. So these kind of migration activities that didn't affect just one product team, but the whole company. We're trying to get folks to move along, and spent quite a bit of time on reporting. So just the act of finding the issue, surfacing it to developers in a way that would kind of let them know there was something to be done. And went, honestly pretty far in that. We, would report some sort of defect in the build log, made sure it was at the end of the build log, so it's the first thing they saw, colorized the output of the build log, colorized the Jenkins output, just kind of went all the way, and it resulted in approximately zero action on the part of developers. So we asked, what would it take for you to do this, right? And they kind of answer sarcastically, do it for me, otherwise I've got something else to do.
They didn't need an external team coming to them with extra problems.
That's right.
I can sympathize with that. I can also sympathize with the position where you must have loads of different projects in loads of different languages with loads of different versions and no consistency
That's right.
at
That's right.
all.
That's
That's
that
a
freedom and
nightmare to manage.
responsibility culture. It guaranteed that there was not a high degree of consistency between the code in one product team versus another.
Okay, so I know you didn't go. It'd be tempting to change that culture and have a bit more enforcement of rules.
Yeah.
I know that's not the road you went down. Give me your pragmatic road.
Yeah, I would say there were certain like attempts in that direction. There was definitely the like maybe we should do a lot more unit testing here inside the company, and these kinds of things just tended to not latch on inside of it. So I think we started with something fairly small. There was a open source project that still exists today called Gradle, which was trying to just manipulate dependencies in Gradle Groovy files. Which seems like a pretty hard general problem because Gradle as a build system is expressed in Groovy. So that's a Turing complete language. And, like in theory,
depending on how funky those files get, that could be very nasty.
Yeah, it could be. So that was also Gradle was an AST manipulation sort of thing. But the scope of the problem was very small. So I think we started with that, just trying to manipulate or massage dependencies and other configuration in Gradle files. And then pretty quickly people started saying, what if we could do this in the main source code as well, outside of just the build files?
Yeah. So how successful first was the Gradle manipulator? I mean, how well did it work in the face of Turing complete configuration files?
I think it's great to be really, really focused on how much you can achieve pragmatically and not theoretically here. So, 90% of the time people define a dependency in a very vanilla, plain way. Sometimes they, iterate over a list of something and, map it to something else and somehow a dependency comes out of that. But if you just discard the exotic cases for a little bit and think, can I solve a large part of the problem? Then we actually got pretty far with that. And
so you tackled Java next? Is that how it evolved?
Java next. And so, the Netflix microservice ecosystem at the time was predominantly Java, with the exception of the studio team, which I think was writing in Ruby, but it was more or less Java across the board.
This is already pretty ambitious, right? Because you must be writing a parser. Are you writing a parser for Groovy and now writing a parser for Java, or are you hooking into their parsers?
Definitely hooking into theirs. So, right. Groovy had some pretty great tools around that already, and some prior art to kind of work with. And Java, of course, the compiler itself is written in Java.
I did not know that.
The parser is quite good, as you can imagine, inside of the Java compiler. So rather than starting from the syntax, we started from already a richer representation, which was the compiler internal AST.
Okay. So take me through this. If I wanted to write a Java syntax tree rewriter, what would I do?
In general, for any language, there's sort of multiple steps. You've got the source code as text. And if you go back to your kind of CS class, on compilers way back when, you have to take that text and tokenize it and turn it into an abstract syntax tree. So there's technologies in the Java ecosystem and others like AntLR, which are fantastic for describing grammars and generating parsers off of those grammars. Yeah. But that's going to get you a syntax tree. So that's going to turn just the text of the code into that tree of syntax nodes. But say you're looking at a method invocation, like I'm looking at a call to the method add on a list.
Right.
I will have some syntax node, which is a method invocation node, where the simple name of the method is add. But from just looking at the syntax, it's not apparent that the receiver type of that method call is list.
Okay.
So you just see the word add. I don't know if that's list.add. I don't know if that's set.add. I don't know if it's headers.add.
So you've got the syntax tree and it's already lost type information. Is that what you're saying?
it's almost like it hasn't yet gotten type information. So you're starting from the source as text.
Oh, right. We haven't run it through
the first step is to produce that syntax tree.
Yeah, of course. Okay.
So a compiler's second phase, or the second step, is to take that syntax tree and now go and start solving for types. So it's, that's its responsibility, is to go and I see this method add. I need to figure out which add it is. And, and so that can be a very complicated process, as you can imagine. It's, it's looking up imports. It's looking at what's on the class path. It's trying to uniquely solve for what add is in this situation.
Yeah, and fun new stuff, fun recent stuff like type inference along the way.
Absolutely. Yeah. You've got generics involved. So that can be a really complicated process. So when I started working on OpenRewrite, rather than starting from an Antilar-like parser, I thought it's best to start from the richest parser available, which is the compiler. And so OpenRewrite's Java, we call this lossless semantic tree, is mapped from the internal compiler AST.
Oh, you've just introduced two new terms we need to break down there. So lossless semantic tree, what's that and why do I care?
Yeah, absolutely. So lossless semantic tree, or LST, is the syntax tree like we were describing, plus all that type attribution information, the solved types for what where add is coming from. Plus, there's one other thing, which is we have to go back to the original source code and go find all the white space and comments and things of that sort, because that stuff is usually discarded very, very early on in the production of the abstract syntax tree. So all that kind of white space gets bolted onto this lossless semantic tree as well.
Because you want to be able to spit out a new version of a file that has all the same white space and syntax, but a new method or a new argument variable name. Yeah.
And that's why we can't use the compiler internal AST directly, because they really have different purposes. The compiler internal AST is an intermediate representation on the way to producing bytecode. And of course, the white space and things of that sort are not relevant to the bytecode, but they're highly relevant to actually printing back out as text of source code and producing a diff. So that's,
I can see that. Do they not hold on to some of that for the sake of error messages?
Yeah, generally, no. Most parsers will just kind of throw away white space as they're tokenizing the source code. So, it may, as part of that tokenization, it may trip over a particular token and fail right there and know where it was. But yeah, it tends to be discarded very early on, and even defined in the grammar as something to be just
thrown away. Yeah. I suppose maybe they're just holding on to line number and column number so that they can go back to the source code and show you that.
Yeah.
So you're saying you've hooked into Java's parser, and then it does the type resolution step. Right. You hook in there, grab that, and then go back to the source code and chew in white space and stuff.
It's like we wind up implementing a visitor over the internal compiler AST, where we're going down all the compiler internal AST types and mapping them one at a time over to OpenRewrite LST model elements that correspond to each one of those. And while we're doing that, we're kind of like, we have like a position in the source code that we're advancing as we go. And so that, we can always see what the prefix or white space on an element really is.
Is this like saying, okay, the next token I'm expecting must be an add, so give me all the white space until we find an add or explode?
That's exactly right. Yeah. And so if the parser is done perfectly, you never have a mismatch of expectations. But that really
never say never.
That's right. That's right. It takes a few iterations to get to that point.
Yeah. Okay. So how much have we got the sense of all the data you've added to this LST, lossless semantic tree?
Almost, but then there's one other thing, and there's this concept we call markers, which marker is just kind of a bare interface that doesn't have any contract to it, but markers are just kind of like a bag of data that we can hang on any level of the lossless semantic tree. In the very earliest forms, we only imagined markers as something that we would hang at the very top level. And so markers are things where we hold information like, what was the Java version used? What were all the types on the class path available at the time this was compiled, whether or not they're used inside the file? What were the transitive dependencies of this project at the time that it was compiled, and how were those transitive dependencies computed? What was influencing those version selections and so forth? And all
Is
that.
So you could do something like you could add some new code that uses array list, and you'd know whether you need to add the import statement.
That's right. That's absolutely right.
And whether it will work. Okay, yeah.
Or we can have conditional recipes where we'll say, I'm trying to get, like a very verbose statement to a simpler one. And, if Google Guava is on the class path, I'll do this. If Apache Commons is on the class path, I'll do that. Or if, so that you can, produce a change that's, that introduces as few additional new dependencies as possible.
Yeah, that makes sense, and probably sticks with the conventions of the project at large.
That's right. Yeah,
and
in general, that concept is make the change look idiomatically consistent in the context of each project that the change is being applied to.
Okay, that makes me wonder. I'll keep going in order, but like an abstract syntax tree, my mind is forking down different roads we could go. But let's stay on this for a bit. So, if you've got this lossless semantic tree, your next step, I assume, is to transform it into a different lossless semantic tree of what you want the code to be.
That's right. That's absolutely right.
Which is going to involve, you've got a tree of Java classes and you're rewriting that tree.
That's right. Yeah. So every change is really just a change on the tree in some way or another.
Right. Take me through an example.
Yeah, absolutely. So you've got I give this example all the time of like changing every integer literal to 42 because 42 is the answer to life, the universe, and everything. Right? And so you in that case you would in this recipe you would implement a visitor. Visitor you can think of as like an event-driven mechanism where you can intercept just literals. And you don't care what's surrounding that literal. Is that literal an assignment to a field in a class, or is it an assignment to a local variable, or is it part of a list array, or list literal? Like, where is it defined? You can just intercept just the literal, and each LST element has data elements on it. So in the case of a literal, it's got a value. And it's got a value source on it. And so you would take that literal and you would say with value and you would change it to something else. In the case of OpenRewrite, we have, this pattern, this pattern called wither, these wither methods that the LST model elements themselves are all immutable value objects. And so when you call with on one of the data elements, you're actually constructing a new literal object and returning that new literal from the visit literal method. And that new object winds up it basically bubbles all the way back up to the top. So if you create a new literal, whatever it's contained in gets a new thing created and a new thing created all the way up the line. We check at every level whether the thing that's been returned below me is the same reference as what I started with. And if it isn't, then a new reference gets created. So that by the time we get back bubble all the way back up to the top level compilation unit, the top level LST element, we can just do a simple referential equality check on that compilation unit to see whether a change has been made somewhere down the tree.
Yeah. It's reminding me a lot of Git. When you change a file down in the tree, the hash bubbles up to the top. Yeah. We keep using the same tricks in computer science.
That's right.
Okay, I'm going to have to push you on a more complicated example. That's for a literal.
Yeah.
Let's say I want to do something that involves a subtree, like I found a faster way to add two strings together. So I want to replace all the string plus string with some function called on those two strings.
Yeah, absolutely. Yeah, so we have two forms of visitors. One we call so there'll be a Java visitor, which is designed to accept only Java LST elements. It kind of filters it at the top, and then you have this set of visit methods: visit literal, visit binary, visit method invocation, all the way down. And there's a special form of that visitor called the ISO visitor. The ISO kind of roughly stands for isomorphic in this case. In the case of that literal thing we were talking about, I would implement a Java ISO visitor because I'm getting a literal in and I'm always returning a literal.
Right.
In this case, I'm just changing the value on it. In this scenario, I'm taking in a binary and I'm returning a method invocation. So there's nothing. So as long as it's just a regular Java visitor, I can always just completely construct a different type than the one that was given to me originally.
Okay. And I have access to walk down my little subtree to find out what's going on and manipulate that.
Yeah. So you would intercept the binary. You're looking for string concatenation binaries. And whenever you find one of a certain characteristic, you just return a method invocation instead.
Yeah, okay, that makes sense. What about context? Can I go up the tree and find out where I'm being called, what I'm being called within?
Yeah, absolutely. The visitor has a concept called a cursor, which just maintains a stack of all the elements that have gotten you to this point. And cursors themselves, the cursors are actually created and discarded as you go up and down the tree. They've got a message passing mechanism on them as well. So as you're kind of like working your way down the tree, you can put messages on a cursor element. And then you might wind up 8 levels further down and you could say, look up and get me the nearest message, or put a message up, somewhere higher up, so that when control returns to that higher level object, I have data that's been supplied to me from, somewhere below.
Right. Okay. Yeah, that makes sense. So, is it the case that I'm always writing these rewrite rules in Java code?
That has been, I think you're going to see very shortly, as we're just about to land the Ruby implementation, that we kind of think of like two phases of language, adding new languages. One, that we're able to write a refactoring recipe in Java to transform that language because the core framework's written in Java. But then the second phase is that you're able to write a recipe in the target language that you're trying to manipulate. And how we're going to achieve that is very different depending on the language. In the case of Ruby, we've got JRuby, right? So it's very trivial actually to write the Ruby program, a Ruby recipe, and execute it on the sort of like general infrastructure.
Yeah.
For other languages, until recently, this was a much harder proposition.
Yeah, because I'm thinking, let me try and pick a good example. Terraform. I know you can rewrite Terraform. Is that something where you're hooking into the Terraform parser? And what prospect have you got of rewriting those in non-Java?
Absolutely. In the case of Terraform, we did actually write an Angular grammar for Terraform and base it off of that. Now, notice in Terraform, there's no type attribution. There's no type solving. So for things like XML, JSON, those sort of things, we tend to start with those parser grammars, like Angular style parser grammars, and build from there.
Yeah, most of those sort of config file things probably, I'm guessing, isn't that hard to write a parser?
It really depends. And in the case of Terraform, Terraform was actually much harder than it appears on the surface, because there's a lot of accidental, I think, grammatical ambiguity to that language that made it almost impossible to write an Angular 4 grammar for it. I think we were able to do it. I think it goes to show, like, friends don't let friends write new languages, right? Unless you're really, really experienced language engineer, which I think Mitchell was not. You shouldn't be doing this. It's very difficult to write grammatically unambiguous languages.
Yeah, I can believe that. And I think particularly in the DevOps world, there's a tendency to start with a config file and keep adding features until you accidentally find it's Turing complete. Right?
Absolutely. I still remember the proof of XSLT's Turing completeness from way back when.
Why does that not surprise me at all?
It was a real shock at the time when I first saw that proof, that's for sure. But that really has influenced my thinking ever since.
Yeah. It makes you wonder what Turing completeness actually means to us, right? I mean, is it a measure of power or a measure of danger sometimes?
Well, from the language engineering perspective, I see it as danger. Yeah, we definitely perceive it as danger.
You must have particular feelings about YAML then. Is that nice and safe?
There's an interesting point here with YAML, which is that one of the surprising things as we developed new languages is we thought we were going to be working on completely different models for each language, like different LST models. But I remember when we started looking at JavaScript and building up rewrite JavaScript, we found that there was like 90+% similarity between the structure of the LST model of JavaScript as Java. And so in a way that's not surprising. They're both broadly C family languages. So there's a lot of, a common history to them, even though they look very different in source code. So when we went to implement that, JavaScript, the LST model, actually extends from J, which is the kind of root Java model, which meant that there was some reuse actually between these languages as well. The change method name recipe written for Java actually works automatically in JavaScript.
Oh, really?
Yeah. And so it's commonly thought that YAML is just JSON in another form. There is actually no shared LST between the two, even though conceptually they're very similar. YAML is quite different, really structurally.
Okay. So JavaScript. No, hang on, because I can believe that JavaScript and Java are roughly similar, especially as JavaScript was explicitly trying to ape Java in many ways because of popularity at the time. But do you not get? JavaScript has some really weird corner cases about coercion and the meaning of white space and that stuff.
Absolutely. And so, coercion, like the way that the languages treat their types, doesn't necessarily relate to the structure of their syntax. So the syntax tree, the model elements are very, very similar. The same, on that same, we call these grammar islands of self-similar languages. On that same grammar island with Java and JavaScript are Groovy and Kotlin, not surprising, JVM languages. Although Kotlin looks very different from Java. So maybe that is surprising. The C# is on that same grammar island. Python is on the same grammar island. Believe it or not, Ruby is on that same grammar island. And Ruby is
one that surprises me there is Python, because I would have thought being like white space sensitive, white space delimited blocks would change things.
It only changes things in that there's less freedom to choose alternative white space formatting, I think is really what it comes down to.
Okay, then let's move on to the third stage of this, because once you've got a new abstract syntax tree, you need to print it out. That's a whole extra boatload of work.
Yeah, the printer itself is actually a visitor. So it's a visitor that just accumulates information to some sort of string builder or appender as it's walking down the tree. So that's definitely part of any language implementation. We tend to develop the printer and the parser simultaneously.
That makes sense.
And so we'll build a whole suite of unit tests that represent all the syntactic variation that we can discover. And the success criteria is that we're able to take a piece of text that represents that example of syntax, parse it into that LST, and then print it back out losslessly. We call that parse to print idempotence, that like you start from source code, we should end with that same source code.
Yeah, so your success criteria is having done an enormous amount of work, you achieve nothing.
That's right.
But in a very interesting place to build from.
Right. That's absolutely right. So, when I was first writing the Java parser, the goal was to take the entire 20,000 Netflix microservices or whatever it was, and prove parse to print idempotence on 100% of those.
How long did that take to get to that point?
I would say it took about 4 months for that initial implementation.
That seems a lot faster than I would have expected.
And that speaks, I think, to the quality in this case of the internal compiler AST. It really is a work of art. I mean, I think depending on the language, the internal compiler ASTs are, well, there are various qualities depending on the language and depending on the implementation, but the Java one is really an amazing piece of work and engineering.
Okay, so some people are going to think me mean for asking this, but I can't resist. Have you tackled PHP, and how's that?
I haven't even looked at PHP. No. I'm curious, though.
I hear Ruby's syntax is famously spicy. That must be a challenge enough.
Very spicy. I'm pretty confident you could not define an ALR grammar or any sort of formal grammar for Ruby. I think it's there's a lot of accidental complexity in Ruby.
Can you give me an example?
Yeah, I think there's this example of a ternary expression where you could say, assume there's no spaces here, 1 equals X question mark. So that's that ternary kind of conditional. And then you could say, the true statement, like, so 1 equals X question mark A colon B. That will fail to compile. But if you write X equals 1 question mark A colon B, that will succeed at compiling. So the only difference here is 1 equals X versus X equals 1. I've just inverted that at the beginning. And that's because question mark can be both it can be part of an identifier. So Ruby can't tell whether that's part of a method name or if it's a ternary operator.
So if the X is next to the question mark, it could be either, and it's
that's right.
And that's why
if it's next to a 1, then 1 question mark isn't a valid identifier. So it's not. So there's things like that are really, how could you teach a grammar or a parser to really recognize the distinction between those two things?
Yeah, that's okay. That doesn't seem like fun, but you must hit that kind of problem on the way out as well, because you've got to be careful not to create rewrite rules that can produce that kind of output.
I think that's true, and I wouldn't say that the LST model prohibits you from creating a change that would ultimately result in a compilation error, but rather, like and this goes back to the pragmatic thing of like, how often would it be that I would be having to do a change method name where the method name, that would result in this kind of scenario? It's not going to be super common.
Yeah. Okay. So you're content in those cases to just say, well, git check out and rewrite the file back that way.
That's right. Yeah.
That's fair. What about, and this is one of those topics that's kind of unnecessarily controversial, in my opinion, but it is controversial. You're writing out some new code. I mean, you can do identity transformations, but you're writing out some new code and you want to keep it in the same white space style as the original code.
Absolutely. Yeah. And so one of the things we do with that, if we go back to how we were defining LST, how we keep all the white space of the original code, we have a whole series of heuristics where we derive what the prevailing style of that project is. based on the white space that we can observe in it. So is it using tabs? Is it using spaces? How is it doing continuation indenting versus indenting? So do I do two indentations to the left, such as like when we use like fluent method builders, or is it just one? That can be language specific. Continuation indenting in Kotlin is less common in 2024 than it is in Java. Some of these rules about what should be continuation indented versus not are themselves, I think, not really well specified and are subject to probably IDE bugs over many years where, something that should have been continuation indented was only indented or vice versa. But then that rule sticks because to change it, to fix that bug would cause, auto formatting a file to change formatting. And so there's this tendency for these intentional or unintentional rules around indentation to stick over the long term. And discovering all that's very complicated. But at any rate, there's a utility inside of the visitor called auto format, where you can call auto format just on a subtree that you're modifying, or you could call auto format on the whole file. And so whenever you're inserting new blocks of code, you tend to call auto format on just that subtree that you're inserting, and it massages it to look consistent with the context of the code around it.
Oh, okay. So I don't have to worry about white space until right at the end of the piece of syntax I'm about to return.
This problem actually goes beyond just white space to also include other forms of style, like import formatting. Should I use wildcard imports, like a star wildcard import or not? How many types need to be in a package for me to use a wildcard import versus not? Is there a different number of types in static imports versus non-static imports to use a wildcard or not? And so that is also something that we're deriving as we're looking at the existing code. And so you may get to a situation where you just remove an import. You remove one type because you've changed it to something else. Is that type covered by a wildcard import now? And by removing the last reference to that type in the file, are there now only, n-1 wildcard imports remaining? And therefore, I should unfold the wildcard into a series of name type imports.
Oh my
and so
God.
That stuff is also kind of rolled up into what it means to add and remove imports at the framework level.
And I can see that you get people mad at you if
Absolutely.
you don't do this. Yeah, because people get really, really hot about these things.
That's right.
That's right. How are you actually doing that? Are you just sort of heuristically tracking for patterns or something?
Absolutely. So, and that's all. It's a algorithm that you can run, that you can implement as a visitor itself. You can look at all the body of code after you've parsed it into LSTs and calculate. We basically, count occurrences of different kinds of styles and then try to decide on what the predominant style is.
So, could you write a rule that said, go through my code base, find the most popular style of implementation that we tend to use, and make the entire code base use that universally?
Absolutely. Yeah. So auto format itself is a recipe that has all of the individual options. So you could derive what the predominant style is and then use that as the input to running the auto format recipe to make the rest in that way. And that's not really something people start with, actually, which is to just go through and add some level of consistency before they do anything else.
Why can I see someone running this, as soon as Jeff leaves the company, going over it to rewrite all Jeff's code, because Jeff was rubbish at that stuff.
I know, yeah.
We didn't have the heart to tell him until he left.
That's right. I tend to avoid this kind of this kind of like conflict by just blaming someone else. Like I'll just say, like, we use whatever the IDE default is. No question asked. That's the easiest way to onboard new employees, especially if you're working in an open source project. You don't have to have a contributors.markdown or something where you use this style or that style. Just It should be, if I clone it with a popular IDE, it should just work. And I don't always love the default styles, but I've long since learned to just accept it.
Yeah, me too. I generally don't love the default styles, but I love not arguing about it at all.
Me too.
And that's worth more to me.
That's right.
Yeah. I like languages these days that ship with an official code formatter that has no options and no flags.
It certainly makes it a lot easier when that's the case.
But you don't get that luxury. You have to live in a world where that isn't the case, right?
That's right. And, there is, Golang's one of those, right? The Golang's one of those that has Go font as part of its kind of core technology stack. And, I think that is representative of Google culture, right? Which is much more control oriented. That monorepo, Google Java format or Go font, like one style to rule them all. There are some good things about that. You kind of refactor more quickly. But it also has consequences. It has consequences on there's a higher degree of a code review and in some ways things don't move as fast. But there's a lower degree of variability in that code base as well.
Yeah, I think you have to choose your battles, which metrics are worth having flexibility over, and which might you just delegate to a computer and not worry about anymore.
That's very true. Yeah, that's very true.
Okay, well, why don't we get in a little bit, as we're veering there anyway, get back into user space a bit, and talk about, as a user of a rewrite tool like OpenRewrite, what kind of things can it do for me? We've talked about reformatting, and how hard is it for me to extend it with my own in-house special rules? Yeah,
and so what can it do for me? I think this system of refactoring, as I'm describing it, this is a rule-based refactoring system. This is very much an encapsulation play, or a belief in encapsulation, that if I provide a base recipe like change method name, that it will be quicker to write common API changes on top of that base. And a recognition that I think that the third party and open source ecosystem upon which we rely is itself subject to a lot of encapsulation. So I think about Spring Boot, for example, really common Java framework. Spring Boot has its own Spring Boot code, but it's also built on top of Spring Framework, which is in turn built on top of all, hundreds of thousands of other open source projects. And so, if you take one of those, like the unit testing framework, JUnit, Spring testing is based on JUnit. So if I solve the problem of moving from JUnit 4 to 5, if I could encapsulate that as a recipe, then it becomes easier for me to write a recipe that moves from, say, Spring Boot 2 to Spring Boot 3. It really requires a level of participation up and down the language stack, from the lowest level library all the way to the big frameworks, to unlock my ability as a user of one of those frameworks to move more quickly between versions.
So you really are going to that level of ambition where you'd replace the whole version of a framework and all its subdependencies?
Absolutely. I think my view of the world, or the world I want to see, is that framework authors are responsible when they make breaking changes for providing the recipe that fixes their downstream consumer. In other words, kind of, you break it, you fix it. Right now, the unit economics of this change are really backwards. I used to work for the Spring team. If I make a breaking change that impacts, 20 million developers downstream of me, or should I have taken the time at the time that I made the change to also provide the recipe?
Yeah.
Why I think it's very, very, very important that such a technology be permissively open source, because only if the technology is truly Apache licensed, or something that's very permissive that allows others to build commercial products on top of it, can we expect the community to really participate in writing, recipes.
Yeah. And then we might hit the dream where languages are a bit less afraid to deprecate old cruft from the earlier versions.
That just as a whole world, we're able to kind of move more quickly towards the outcome we want to be. We're not kind of dragged down by the technical debt of 10 years ago,
Yeah. But one of the blockers to that, I would have thought, will be the predominant, like you can write transformations for different languages, and you support quite a lot on OpenRewrite, but you're kind of pushed to writing those rewrite rules in Java.
And that's why it's very important, I think, that we do the two-phase language support, that you're able to write recipes in the language that you're trying to transform. And so the first example you'll see of that is with Ruby coming out here, where you can write a Ruby recipe to transform Ruby. It's very important, I think, to provide a native recipe authorship experience in the language you're trying to transform.
Do you think that will tend to be the job of the OpenRewrite maintainers? Or do you think it will eventually be something that language maintainers themselves support?
I think
if I create Crislang, would I then be expected to write a Crislang parser and printer and visitor?
It's a good question. I think, even below the language level, at the framework level, I think what I want to see I believe a little bit in competition here, that I'm thinking of, like we mentioned Spring, but there's also competitors to Spring in the Java ecosystem. Red Hat has Quarkus, Oracle has Micronaut. Those are competing for market share with Spring, or developer mindshare. Like, what should I build my application in? Yeah. And so as kind of call out, I think Oracle for the last couple of years has, on every breaking change in Micronaut, has provided a recipe that fixes that breaking change. So Micronaut was really leading the way on that experience of you can move easily between major versions of Micronaut. That should be a reason why I consider Micronaut as a developer over Spring.
Yeah.
And if I opt out of that as a framework author, then it's just one of the decision points that I'm making as a user.
Yeah. So you're seeing it as a competitive advantage if you do choose to get involved in
Absolutely. That. And now imagine it from a vendor's perspective. Suppose I'm trying to I'm starting a new application monitoring platform, and I'm trying to compete with Datadog. I know that I have to go through and replace Datadog specific, like vendor lock-in sort of like source code with mine. If I provide those recipes, then I expand in my customer base much more quickly than I would have otherwise.
Yeah. And when one of your competitors goes bust, the first person to write those rules will get the lion's share of the people looking for a replacement, right?
Right.
This is possibly pushing it too far, but how ambitious do you think you could get if someone said, I've got this Ruby on Rails site and I'd like to migrate it to Django on Python?
Mm-hmm.
Do you think you'd ever get that far, or is that pushing the boat too far?
My tendency is to think it's too far, but then again, like, I change over time in this too. So broadly, I say there's creative activity in software development, and then there's really mechanical activity. And while it's hard to precisely define what's what, we feel it when it's mechanical. I used to, for a long time, I watched, baseball in the United States at St. Louis, watched St. Louis Cardinals, and they have 162 games a year. And I used to reserve maintenance activity for Cardinals baseball games because baseball isn't quite interesting enough to consume my attention, but neither is mechanical activity and code. So I would do them at the same time, kind of like, so, do you consider a Rails to Django migration to be creative or mechanical? Sometimes it can be more mechanical than we expect at the beginning.
Yeah. I suppose if you're using the vanilla stuff rather than some particularly funky, I bet different libraries is where you fall down.
It'll all just be a matter of diminishing return, right? Where is that point of diminishing return for me?
Yeah. At what point do you Would you be better off just doing it creatively rather than trying to come up with a rule that can do it mechanically?
That's right.
Yeah, I can see that. Okay, so if we're getting into the land of multiple languages, does the game change when you start to try and apply this tool to whole projects or even whole companies worth of projects?
Explain what you mean by that.
I'm just thinking, so if you wanted to call OpenRewrite on Google or Facebook's monorepo, now you're dealing with a vast number of languages and a vast code base. Can you scale to that kind of size? Or are you keeping the size of the code base small and focused?
I think so. Scale is certainly one of the points of like where, as a company, Modern, we've taken this LST, this lossless semantic tree, which in the open source tools we're producing in memory. And we've taken this extra step to figure out what it means to serialize it to disk, which itself is pretty tough, a problem, because these trees are actually cyclic in nature, especially the type attribution information.
Yeah.
There's a lot of work to do in cutting cycles and then reconstituting them as cycles on the other end, and this sort of work. But once you have a LST on disk, that's the sort of like fundamental block upon which you can build a horizontally scalable system to operate on hundreds of millions of lines of code. And so I think when you're running an OpenRewrite recipe on one repo, the cost and time is dominated by the parsing, not the recipe running.
I can believe that. Yeah.
And so you can still achieve a great degree of value. You parse, you run a recipe, you made the change, great, move on. But then when you want to do that for the other 10,000 repositories, you wind up sort of bearing that cost more and more. If the recipe is really, really well battle tested, think of like the Java 8 to 17 recipe at this point, it's still arguably okay to bear that cost, that like parsing cost once, no matter how many projects you have. And so when we heard Adam Selipsky, the AWS CEO, get up on stage and say that Amazon migrated 1,000 Java applications from Java 8 to 17 in its own code base in 2 days. He was doing that with open source, but they were able to do that because that recipe is so well battle tested. If you were developing a new recipe that was, making some sort of, you would want to be able to iterate on it, many times over again.
Yeah.
And in that case, that the cost of parsing really, really, really adds up and starts to be an impediment.
So what do? Do you attach your LST to the hash of the source file or something?
That's definitely absolutely. So, the goal would be clone dozens or hundreds or thousands of projects, build the LST and keep that as an artifact, as both permanently in the artifact store and, locally on, where you've got these repositories cloned, and then you can do a recursive operation on a whole directory structure, running a recipe on every repository root that's found in that directory structure. Those kinds of experiences where you want to be able to operate on a large code base.
Okay. What about something less invasive? Like, I'm assuming I can use the same system for code linting, right? Where I don't want to change anything. I just want to be warned of patterns. Absolutely.
Yeah. So this is a discovery, I think. Remember we talked about markers a while back, and we were originally using markers to put information about like what Java version, what dependencies existed, those kinds of things on the LST. But because a marker can exist anywhere, Modern's co-founder Olga Kundic a couple of years ago, kind of pioneered the idea of like, what if we just used a special kind of marker to indicate where something was found as like a search result. And so we do have an interface called search result, which is an extension of marker. And a refactoring recipe, rather than making a change to the LST model, can just add a search result marker to any LST element. And then we have a choice of how to render that search result marker when we go to print out the LST. So we could print it as a little comment with an arrow pointing at a particular place, or you can you could render it any way that you want to sort of like actualize it in the source code. Yeah. But that unlocked a search capability. So curiously, search wound up being a special case of transformation.
Oh, yeah. Yeah, I can see that.
Which is not what we expected at the beginning.
Presumably quite sophisticated search, because you've got all the type information there too.
Exactly. So one of the really interesting examples is find uses of deprecated methods, where we're able to look at every method invocation in a body of source code and tell whether that invocation is deprecated at the time that it was compiled. There's nothing in the source code itself that would indicate to you that something is deprecated. It's something that's n levels up to type attribution information.
Yeah. Yeah. Okay. That makes sense.
So we start to take that one step further. And the search result marker was the first kind of like foray into search. The second foray was to that recipes can now define what's called data tables. And this is an open source as well. And data tables are just columnar data, like it's a columnar format. Like, if you were just to emit a table, what would the column names be and what are the data elements on them? And then a recipe, as it's going through its normal visitor, it's like working through the code base. It can insert rows of that column structure into a table. And then at the end of the recipe, we can just actualize that table in an Excel file or a CSV or whatever columnar output that we want to achieve. And then if we do that across hundreds of repositories, we're actually collecting data across, potentially the entire code base. So we use this to do things like find sensitive API endpoints that produce PII, whether or not that PII is visible at the top level return or it's buried somewhere in the model object that you're returning. Find vulnerable dependencies, find usages of particular APIs. And one of the columns in the case of find methods in the find methods data table is the actual code snippet of the method call. So if you're doing an impact analysis, I'm thinking of changing this API, you can start by just finding all the usages of the API and you quickly get an Excel table of all the variations of the way that API is used across the code base.
Yeah. Or there's been a security warning on some method in some dependent library. Do we use it? Do we use it anywhere important?
Yeah, that's right.
Yeah. Oh, that's quite cool. Okay, so I should probably, for time, I should push on to my two last questions, which is, the first one is, let me think of an out-of-band language, Gleam. I'm going to pick the language Gleam. And I decide I would love to have this capability for Gleam. Should I take inspiration from you and hook into the parser and write my own lossless tree and a printer, which sounds like a bunch of work, but not desperately? Or should I just try and support Gleam in OpenRewrite? Which do you think would be the path of least resistance?
I think that there's some common support in OpenRewrite that would help you make progress. This question, I think, partially depends on whether how hard to interop between the OpenRewrite sort of like Java-based infrastructure and Gleam's compiler really is.
Right.
In this way, I was actually pretty concerned for a while. How are we going to support a language like C#, which there's not really an obvious way to run C# code on Java. I can run Ruby code on Java easily. I can run Python code to some extent. JavaScript.
Because of JRuby and JPython, yeah.
But C#, what am I going to do? And I think lately, there's been some really amazing work. There's a project out there called Chicory. It's dlibso or dylibso, dylibso /Chicory on GitHub. And Chicory basically enables any WASM compatible binary to run on JVM.
Oh, okay.
And so
Yeah.
that's unlocked a world of opportunity, I think, for C#, for C++, for Swift, for those languages for us to build parsers. So we would build a parser in Swift, but then we could, and potentially even build a recipe in Swift, but then that can execute inside the context of the sort of OpenRewrite recipe scheduler. So that I think is what we're going to see here in in 2024 as we expand into C#, and that'll provide the kind of like template that others will be able to use as well.
Yeah, there's a use case for WASM I wouldn't have foreseen when they announced the project.
Me too.
Yeah, cool.
I've been kind of like, deriding it as like, Corba 2 for years, and I might have to keep my words on this.
Well, it's good to be humbled occasionally by the well. Yeah. Okay, so if I don't want to go to all that work, I am going to get myself a JVM and download OpenRewrite. Where should I start with it?
Yeah, absolutely. So on GitHub, the organization is OpenRewrite, and there's a bunch of different repositories inside of that. OpenRewrite/rewrite is where most of the the stable language parsers are. But we have modules like recipe modules, rewrite Spring, rewrite logging frameworks, etc. That are community maintained for various applications.
Okay, cool. And so I'm pretty sure I'm not going to go to this amount of work. I will just leave you as a final unsubtle hint. It is possible to call Haskell code from Java. So,
is it really?
Yeah. A company I worked for worked on a bridging project for it. So
and the other direction as well?
I think you can go in both directions if memory serves.
What is that project called?
Oh, I will have to find it and send it to you and put it in the show notes.
Okay, very good. Yeah. We'd be curious to see.
So in case you're tempted down the line to add Haskell support. Yeah. Cool. Right. I think I should go and at least try and lint some code, if not rewrite it entirely. Okay. So, Jonathan, thank you very much for joining us.
Yeah, thank you. It was a pleasure.
Thank you, Jonathan. And I have to correct that last thing I said there. I double-checked. There are actually 2 libraries, one for calling Haskell from Java and one for the other way around. Link to both in the show notes if you want them, along with the more relevant and pressing link to OpenRewrite if you want to give that a try. It has got support for an impressive list of different file types and languages. And when you think about the amount of work that takes, I think it's worth checking if one of your languages or files is in that list. It might well have a place in your toolbox. Before you go and do that, if you've enjoyed this episode, please let us know. Give it a like if you've liked it. Share it with someone if you know someone who might enjoy it. And make sure you're subscribed, because we'll be back next week with another interesting voice in the world of software development. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Jonathan Schneider. Thanks for listening.